Hi everyone, welcome back. In this video, we will keep working on 2016 Gauss Contest Grade 7 Part B. Question 11. The diagram shown contains octagons and squares only. The ratio of the number of octagons to the number of squares is. So we can count the number of octagons and the number of squares respectively in this shape. So we have 1, 2, 3, 4 rows of octagons and 1, 2, 3, 4, 5 columns of octagons. So the total number of octagons would be 4 times 5, which is 20. And the number of squares, we have 1, 2, 3 rows of squares, and we have 1, 2, 3, 4 columns of squares. So the total number of squares in this shape would be 3 times 4 equal to 12. So if we simplify this ratio by dividing 4 on both sides, we would have 5 to 3 at the end. So option E would be correct. Question 12. In the sum shown, P and Q each represent a digit. The value of P plus Q is. So we can, for this question, we can start from the ones digit. So we have 3Q adding together equal to 6. So we have two scenarios. The first scenario is that 3Q is equal to 6. And the second scenario is that we actually carry 1 to the next digit. So that would be equal to 16. However, for the second scenario, Q will not be an integer. So we must discard this possibility. So we only need to deal with the first possibility that 3Q is equal to 6. So Q is equal to 2. So the question becomes, if we put this, if we substitute this 2 in, we have, if we now look at the 10th digit, we have 4 plus P equal to 7. So P is equal to 3. And if we check with the 100th digit, 3 plus 3 plus 2 is indeed 8. So we have Q is equal to 2, P is equal to 3, so P plus Q would be equal to 3 plus 2, which is 5. 13. Question 13. A larger cube has volume 64 centimeter cubed. A smaller cube has edges that are half the length of the edges of the larger cube. What is the volume of the smaller cube? So if a cube has volume this much, we need to cube root it to find the side line, to find the edge length. We would have 4 centimeter. And the smaller cube has edges that are half the length of the edges of the larger cube, and we just calculated the length of the edges of the larger cube is 4 centimeter. So this edge, the edge length of the smaller cube would be equal to 4 times 1/2, which is 2 centimeter. And the volume of the smaller cube will be equal to 2 times 2 times 2, which would be equal to 8 centimeter cubed. Question 14. Ahmed chooses 2 different items for a snack. His choices are an apple, an orange, a banana, and a granola bar. How many different pairs of snacks could he choose? So this is a typical combinatorics. So we need to choose 2 snacks from the 4 different possibilities. So it is a 4C2 problem. The order of the 2 snacks that we are choosing does not matter, because no matter which snack we choose first, the combination will always be the same. So 4C2 would give us a 4 times 3 over 2 times 1, which is 6. So we have 6 possibilities to choose the 2 different snacks from the 4 snacks. Question 15. Sophia did push-ups every day for 7 days. Each day after the first day, she did 5 more push-ups than the day before. In total, she did 175 push-ups. How many push-ups did Sophia do on the last day? So this question is an arithmetic sequence question, because for each day she did 5 more, and this is the common difference. So we're looking for the last term, and the last term would be Tn equal to T1 plus n minus 1 d. So we know T1, which is we do not know T1 in this case. We know n and we know d. So we want to figure out T1 from this sum 175, because that's the only other clue that we have. So if we write out the formula of the sum of an arithmetic sequence, we would have sum of the 7 terms would be equal to t1 plus t1 plus n minus 1d, this is the last term, times 7, which is the number of terms, divided by 2, or times 1/2. So we would have 2t1 plus 6, because this is 7 minus 1, so this bracket will give us a 6, and d is 5, so plus 30 times 7 times 1/2 is equal to 175. So if we solve this question, or solve this equation, we would have t1 is equal to 10, which means the first term of this arithmetic sequence is 10. So Sophia did 10 push-ups on the first day. So if we substitute t1 back into this formula, we would have 10 plus 7 minus 1 times 5, which will give us a 40. So again, from the sum 175, we can figure out the first term of this arithmetic sequence. And then we substitute this valuable data back to the last term formula, to the general formula, we can find the last term. Question 16. Each of square, triangle, and kite represents a non-zero number. If one square is equal to 3 triangles and one square is equal to 2 kites, then what would a square plus a kite and a triangle equal to? So we know that since one square is equal to 3 triangles, so it would have 1 squared plus 1 kite plus 1 triangle is equal to 3 triangle plus 1 kite equal to plus a triangle, and we can see that option B satisfy this equality right here. They're the same. Question 17. Triangle T is reflected once. Which of the following triangles cannot be this reflection of triangle T? So we can see that triangle T can be reflected over several different lines. So if it's reflected over this line, then the reflection would be B. If it's reflected over the y-axis, the reflection would be A. If the triangle T is reflected over the x-axis, then the reflection would be E. And if T is reflected over this imaginary horizontal line, then the reflection would be D. So the only triangle that is left out would be C. So C is not a reflection. Question 18. The mean, which is average of a set of 6 numbers, is 10. When number 25 is removed from the set, the mean of the remaining number is. So for average question, we always need to keep in mind that the formula that we usually use is the number of total entities is equal to number of entities. I'll reword the first part. Sum of entities equal to number of entities times the mean. So we can see that if a mean of a set of 6 numbers is 10, we would have the sum of all numbers be the number of entities, which is 6. We have 6 numbers in the set, and the average is 10. So the sum of everything would be 60. And when the number 25 is removed, the sum of the rest of the numbers will be 60 minus 25, which is 35. And this is the sum of, be careful, not 6 numbers anymore. It's 5 numbers because 1 number is removed. So we would have 35 as the sum of all entities. We have number of entities is 5 numbers, and we are looking for this mean. So it would have 35 divided by 5, which is equal to 7. Question 19. Susie's 5-meter long ribbon has shaded and unshaded sections of equal length as shown. Points A, B, C, D, E are equally spaced along the ribbon. if Susie wants a ribbon that is 11 over 15 of the size of this ribbon, at which point could she make a single vertical cut? So first we could calculate what's the length of each section right here. So we have 5 equal sections on this ribbon. So for each section, the length will be equal to 5 times 1/5 equal to 1 meter. So each section is 1 meter. And we can see that ABCD, these 4 points, separate this one section into 3 equal sections, yes, smaller sections. So we can say that AB is equal to BC is equal to CD is equal to DE equal to the length of one section divided by a third, which is 1/3 meters. And then we can go on and calculate how long does Susie actually want from this ribbon, which is 11 over 15 of the size of this ribbon. So we have 5 meter times 11 over 15 of the size of this ribbon, which would give us a 11 over 3 meter. And we can see that maybe we want to include the first 3 whole sections with 3 meters. So let's go on and subtract this 3 meters from the 11 over 3 meters and see how long do we still need. So we still need a 2 over 3 meters. And since one smaller section is 1 over 3 meters, and we want 2 over 3 meters, so we can see that this is actually equal to 2 times 1 over 3 meters, which means we need 2 of the smaller sections. So we need AB and we need BC. So we can make a single vertical cut at point C to satisfy the desired length. Last one, question 20. In the diagram, 4 different integers from 1 to 9 inclusively are placed in the 4 boxes in the top row. The integers in the left 2 boxes are multiplied, and the integers in the right 2 boxes are added as shown here. The operation. The final result is placed in the bottom box. Which of the following integers cannot appear in the bottom box? So, for this question, since it's a multiple choice, we can go on and try each option out. So let's start with 7 because it's the simplest. So if we have 7 in the bottom box and we want to use 1 to 9 to fill out these numbers. So let's go on and think what's the minimum value that we can put in this box. Since it's from 1 to 9 it's all distinct, so the minimum would be 3 to put in this box because it's 1 plus 2. So let's go on and do it from the minimum. So if we have 1 and 2 placed here, we would have 21 in this box, and we do have a possibility to satisfy this 21, which is 3 and 7. So 7 does work. Next possibility, let's go with 9. So if we have 9 here, the number that goes into this box must be 3 times 9, which is 27, since we still want to keep it the minimum. So we do have a possibility to fill these 2 boxes out to meet a product of 27. So 9 also works. Next, let's go with 24. If we have 24 here, it times 3 will give us a 72. And we does also have a possibility to fill out these 2 boxes to meet a product of 72, which is 8 and 9. So 24 also works. And the next possibility, let's try option A, 16. If we put 16 here, we will have 48 here. And we can do 6 times 8, which is equal to 48. So A does work. So we're only left with 20, and let's try 20. If we go with 20, we would have a 60 here. And frankly, we don't have any possibilities to fill out these 2 boxes with any 2 distinct integers from 1 to 9 to meet 60. If it's 5 times 12, this 12 exceeds the boundary of 9. So 20 doesn't work. So the answer to question 20 would be option D. And I think that's all for 2016 Gauss contest, grade 7, part B. Thank you for watching.